something to say, something to say.
Hey everybody, how's it going? This is Our House 21, and this is a long time coming kind of video. So, almost a year ago, I received a shipment from Boca Bearings with a set of ceramic bearings for me to benchmark and see how well those guys do compared to the stock bearings. And in that year, I have not been able to set aside the time to do the full benchmarking and upgrades that I plan to do. So now I'm finally sitting down and I'm finally just knocking it out. So like I said, this is long time overdue, but what you have in front of you is, this is Dizzy, and I'm running my Castle 2650 motor with the Mama Monster speed control and stock gearing. So he's, well, no, I'm sorry, not stock gearing, stock bearings. The gearing is mod 1, and its theoretical top speed is well over 100 as it's currently geared. Now, this battery, this is a SMC 3S. This battery does not have enough power to get this car to 100 miles an hour. However, with no load, it will be plenty fine to get the wheels up to a top speed that are quite excessive. So, here's the setup, and you see right here, I've got my Turnigy battery meter here, and if you guys can read, it's actually indicating 12 volts. There's no power on it. The amp load is 0.1 amps. That's just just general load of the system. So basically, for this experiment, I'm going to run this guy up to full throttle, a slow run up, because I'm not trying to get an assessment of how much force it takes to spin up the tires itself, because that's a whole different conversation. But so basically, this guy is going to spin up to its maximum speed, and I'm going to get a reading of what the power, the sustained instantaneous power is to just maintain maximum RPM. Then I'm going to repeat this experiment with the ceramic gears in place, and that will tell me how much power I am saving. So how much less energy I'm losing by going from ceramic gears, or to ceramic gears from the stock gears. Okay, I said that wrong again. That's going to tell me how much energy I am saving going from stock bearings to the ceramic bearings. So this should be interesting. So let me go ahead and fire it up. You hear the beeps. Okay, and I'm just making sure that everything is clear. Okay, so I don't have anything touching. And time to run this sucker up. Okay, that was interesting. So I got a sustained reading of 265 watts. So, and the maximum amps that I was pulling was 27.8. So that's not too bad. So I'm going to go ahead and do one more pull. So, and it's interesting for those who are, the speed freaks among you, see that the voltage actually dropped down to 11.5 volts, just clean, with no actual drag from the drive line. Well, it's all drive line drag, but it didn't have any actual drag from air. So this is telling you that just the fact of spinning up your wheels actually pulls quite a bit of current. Now I would just touch on this because you see it hanging here. In order to make this wiring work, so I can get this guy, the meter, to so you can see it, I put in my little parallel battery connector as an extension cord. I really should have taped that up. I'm using bad discipline. I'm a bad engineer. Bad our house. Smack my hand. Okay, but you know, it's safe. There's nothing touching it. It's out. It's clear. So I'm going to go ahead and do that one more time, just to make sure that we believe the number. And I'm going to pull this a little closer to the camera so you can see it a little bit better this time. And but also other things to just note from the setup. You saw how little vibration there was. These are Jayco foams. They haven't been balanced, but it actually they like high speed. They seem to do a pretty good job. So I'm going to go ahead and I'm going to spin it up one more time. Now that was interesting. Okay, I don't know if you guys noticed that, but as the longer I held the speed, the lower the instantaneous draw went. It actually started off at around 300 watts, but then went down to about 250. That's very, very interesting. I'm going to go ahead and do this one more time, and I'm just going to go ahead and just run it. I'm just going to go ahead and run it down. So this might take a little bit, but actually before I do that, let me just double check to make sure that everything is good, that I'm not smoking anything. Because I wish I had smell-o-vision. I can actually smell what smells like oil, and that's probably just my bearing grease I use back here. So, but because I just greased my bearings, I keep saying bearings, I just greased my ears just a little bit ago, so I have a feeling that the grease that I put in there is just settling in and kind of drying out. So that's very interesting. Let me do something. I just picked this guy up a little while ago. This is a little IR thermometer. Let's go ahead and see what the temperature is of the gears. Okay, I'm showing 129 degrees. Let's try it one more right here. Okay, I've got 135 degrees. Let's see what the motor temperature is. Motor temperature is only 89 degrees, and that's about what it should be, because it's really not, it's not doing much, and the ESC is only at 78 degrees. So these guys aren't really working too hard at all. But okay, let's see here. Okay, so I've got my pinion gear in here is at 140 degrees. Well, that's 142 now, so it's cooling down a little bit. Okay, so I'm going to go ahead and do one more spin up. This time I'm going to do something a little different. I'm going to try a different lubricant. Let's see if that actually drops the gear temperature. Okay, so that was I just put a couple drops of a lighter oil in here, because I have a feeling I burned off most of my actual gear oil. Oh, it shouldn't have. I mean, this stuff, it should be stable to high temperature, so it should be okay. It just probably just been a thin little film on it. Okay, so let me go ahead and spin up. And this time, like I said, I'm just going to run it down and see what happens. So let me turn it back around so I can see the meter. So if this holds, what I should see is it start off high and then slowly creep down to to a lower power level. So let's see what happens. Okay, here we go. That was kind of cool. So what I observed there is, okay, the max amps didn't move from 28.9, so I need to reset that actually. So give me a second, let me reset that. Because I think what's actually happening is my, okay, let's do that again. Reset. Okay, so let's go back. Okay, so now we're reset to 0. I'm going to do one more pull, and let's see what the maximum amps goes to. Alright, so I'm going to do a quick check of temperatures to make sure that nothing's overheating. So let's get in here and check out the gears. Okay, so the spur gear, 175 degrees. Okay, let's get in here and check out the pinions at. Pinion gear. Got 186 degrees. See if I get on here. Motor. Motor's only at 120 degrees, 126.5. And the ESC. The ESC is at 86. So the motor and ESC are barely feeling this. Okay, so that says that, you know, and you saw I did a sustained pull. You know, a typical speed run is, you know, only a few seconds long. So I'm holding it sustained. So that's actually much more, that's much more abuse than you would ever expect to see in the course of a normal speed run. So, all right, so since right now the battery voltage is at 11.4, so I might as well just go ahead and just run out this battery. And in case you're seeing what I'm doing, I'm just, since I just freshly oiled this, you know, I had a little bit of grease just kind of flying. I'm just wiping off a couple surfaces. So I'm just going to go ahead and just run down this thing to cut off. You know, so because this is actually interesting data. Because now what I can do, like I was saying before, the power is falling, but power is a product of voltage and amperage. So as the battery starts to run down the charge, its voltage will fall, which means that total power that it can give will fall. So you can watch those things go down. But I can use that data, put it into a graph afterwards, and then basically back out what the actual mechanical drag is along at different RPM. As you know, the RPM that the system goes to, because this is essentially still very lightly loaded, so it should be going to the maximum engine RPM for this gearing. So the engine, I mean, I can figure out the wheel RPM based upon what the kV rating is of the motor, 2650, and what the what the gears are, which I know. So all that should, like I said, will give me the ability to track speed as it goes down as a function of voltage, and then turn that into a term that gives me the amount of drag per RPM that I see. And that's going to be interesting to see if that, it should remain constant, but it'd be interesting to see if it doesn't. So I can take all that data and pre-ceramic gears and with ceramic gears. I keep saying gears. I can take all that data, pre-ceramic bearings and post-ceramic bearings, and see how that all goes. So let me go ahead and just finish up killing this battery. Actually, I'm going to stop for a second. I'm going to get some ear protection. This is loud. We'll go ahead and plug this guy up just to see what the battery's doing in more detail. And see what the battery temperature is. 85 degrees. This is really lightly loaded for it. Check the gears. Still at 175 for the spur, and 185 for the pinion. Okay. So about 3.7 all across the board. Actually, that's not too bad. I think I'm going to stop here because this is just about at what storage voltage should be. So that'll be fine. All right. So now next thing you're going to see is me actually tearing this guy apart and giving you a walkthrough of how you change the bearings in a monster like this. So this is actually going to be kind of fun. So I haven't done a video like this in a while, so yeah, I hope you guys like it. Okay. So, you know what I think I'm going to do? I'm going to break this series up into a few. So this will probably be posted as its own video. So in that case, thanks for tuning in, guys. Stay tuned. This is, like I said, this is part 1. This is the bearing benchmark. So I'll post a little bit after this, after I do a little bit of number crunching, to just kind of see how much drag I really was getting, and that way I can have a good assessment of what a difference ceramic bearings make, if at all. Alright, so guys, remember to like, comment, subscribe. Remember to give me some feedback. Let me know if you think this type of series is interesting to you. And then, I welcome all comments. Alright, so until next time, remember the mantra, fly, fix, fly. Break it, fix it, do it all over again. Like I said before, remember to like, comment, subscribe, and get out there and have yourself a ball. Keep tuned. Our house 21 signing off. Peace.